Hey guys, it's Miss Chang here. So in this video, I'm going to be explaining to you guys about intervals and set notations. But first, let's go over some basic vocabs. Like, you guys have probably heard different types of numbers, maybe something called natural numbers, whole numbers, integers, but we are going to define and give examples to what each one mean because they are different from each other. So let's take a look at number one. So number one has numbers like 1, 2, and 3. They look kind of like whole numbers, and they're positive, just positive numbers. So that tells me that this is what we call natural numbers. So let me put that in the box here. Got my pen. Natural numbers. So typically back in the olden age, we started out with numbers that are positive and whole numbers. So that's how I kind of like to think of natural numbers, is being numbers that we kind of initially started off with when we're thinking about mathematics, is just those whole positive numbers. Like, we hadn't thought about negative numbers yet. We hadn't even thought about zeros yet. But later on, we basically added more numbers because we dealt with more situations where we needed zeros. So when you have a zero and you're counting positive numbers, that's what we call whole numbers. So this is a set of whole numbers. Oops, if I can spell. Whole numbers. And so this is positive numbers, but also counting like zeros. So positive numbers and zero. And then the next one here has negatives, numbers, and zero, and positive numbers. So when you have a combination of this, but they're still whole numbers, this is what we call integers. So integers can have negative numbers and zeros. The next one we have here is, notice we have some fractions, we have some decimals, right? And so these decimals, like 0.92, I can actually write that as a fraction, right? If you have 0.92, so if you have this guy and you want to write it as a fraction, we usually put it over 100, right? Because this is to the 100th place, so we can write 92 over 100, and we can simplify that too. But what I'm trying to say here is that if I can write that decimal as a fraction, so if I can write something as a fraction, we call that a rational number. So anytime you hear the word rational, I want you to think of it as fraction, numbers that you can be written as a fraction. So we have covered rational numbers. Let's take a look here at our next set. So our next set of numbers has looks like a number that's decimal place keeps going on and on forever. And this is a special number. It's 3.14, which you guys probably have learned this before in geometry. It's the number pi. So oftentimes we get into numbers that we can't represent as fractions. And when we can't represent them as fraction, we call them irrational numbers. But if we can't represent them as fraction, that means that their decimal place goes on and on forever. And that's why we don't want to write 3.14 all the time. We use a symbol instead to represent it. This is also a number kind of like pi. It goes on and on forever. It's 2.718, and then it goes on. And it's represented by E, and we'll talk about E, the number E, in the second semester. But like I said, numbers that can't be represented with a fraction or decimal, or numbers that have decimal places that go on forever, are what we call irrational numbers. Can't be written as a fraction. And that's all the type of numbers that generally we talk about. Now, the one that I didn't cover here is, let me highlight above, is real numbers. Basically, real numbers are all the numbers that are here. They include every type of number, and I'm going to show you using an interval line or an interval graph line. But first, let me explain about sets and subsets. So a set is a collection of objects. So it's basically, think of it as like a bag that holds stuff, or what we call is elements. And so we use braces, just right here, braces, that look kind of like these, they kind of look like parentheses, but they have these weird pointy ends on the side, so we call those braces. And so we use that to represent a set, and then we put stuff inside of it. And so in this case, I'm just going to do an example here. I'm going to just put 3 numbers or 3 elements in here. I'll just keep it real simple, 1, 2, and 3. So this is a set with 3 elements. And we can get really specific here what type of sets we have. We don't have to constrict it to 3 elements. We can do an infinite amount of elements, but we have to define what that set holds. So let's say we defined a set that had natural numbers. So like 1, 2, and 3, and it would go on and on. So I'm just going to put some dots here. Let me redo that. There we go. So I close the brace. And so this set is a set for natural numbers. Oops. And there we go. So sets generally are represented with these braces, and then they have elements inside of them. So I just happen to use numbers. And then a subset is a set contained in another set. So I want you to think of a subset being a set, and then within it you have stuff inside. So let me show an example here. So if I were to use this set right here, I can create a subset where I take 2 of the numbers. Let me just take 1 and 2. So this set here, or subset, so is a subset of the original set 1, 2, and 3. So subset is like a partition of the original set. So now let's define what exactly is an interval. So we've heard of intervals before. So intervals is all the numbers between 2 given numbers. So I'm going to write that in my box. And so I'm going to show the interval of an all real number line. And basically, intervals can be represented by an inequality, which I'll show you. These are like inequalities. And you can also use a graph, like a number line graph, which I'm going to do here as an example. Or you can use an interval notation, which I will show later on in the next video what an interval notation looks like. So when we're talking about real numbers, we're talking about all the numbers that ever existed on a number line. So in this case here, usually you start out with zeros, and then this side's going to be positive numbers like 1, 2, and 3, and it then goes on and on to infinity. So I'm going to use that weird figure 8 symbol to represent infinity. And then on the other side, you have some negative numbers. So real numbers have to include positive and negative numbers and zeros. So this goes to negative infinity. But real numbers can also have irrational numbers and rational numbers. So we said before, rational numbers are numbers that represent as a fraction, like 1/2. Irrational numbers are like the number pi, which is 3.14. So I just wrote a little bit over 3. So when it comes to the real number line, it covers all the numbers from negative infinity, so negative numbers, all the way to positive infinity. So that's all the numbers that exist on the line, which makes it the real number line because it covers all the numbers.